Hello, everyone. Welcome back to Advent of Code 2024. So far, been a good year for me, I think. I mean, none of the problems have taken me less than an hour, which is a little embarrassing, but I'm not really trying to do them quickly. I've solved them all and not really felt totally lost with any of them, except for that one where what was that mistake I made? It took me an hour to track down that I was aborting a search early. I don't remember what day it was. Anyway, before we start on 12, a couple of updates on the solution to 11. I realized that the whole separating out this split function that took like a rock or a stone, assuming its label wasn't 0, and produced either like nothing if you could split it and a pair if just a pair if you could split it. It was just much simpler to inline that, and also a little bit more philosophically correct. Like, now there's just one place where all of the rules are defined, rather than having to communicate through this weird maybe. And then I also happened to see, that someone else had memoized basically the step function, which I was a little bit surprised by. I was like, it's not that expensive, is it? The expensive part is, managing a bazillion stones. And so I thought, I'll just throw in some memoization on my own Blink thing and see if it makes any difference. So using memo tree, which, is a library that memoizes a function whose input you can build a search tree for, basically. So ints, obviously, you can search ints by I assume the way they do it is binary search up until you are above the int. Exponential growth search up, and then binary search down. I haven't looked in a while, but that would make sense, right? Anyway, so it memoizes a function that takes, in this case, an int as an input. And so now instead of Blink taking m as an argument and then doing its work, first Blink, before it receives m at all, creates a memoized copy of step, and then uses that memoized copy for any m that it gets, the same single memoized step function. This is the way that memoizing in a purely functional language typically works. Obviously, in Haskell, you can introduce state or IO or whatever and memoize stuff by hand in a set, but unless you have a special reason to do so, it's usually fine to just use this idea of a memoized function. The way that it works, which is interesting, because let's actually talk a little bit about memo tree. The memo function, I was not really actually prepared to do this. So if we ask what is the type of memo, its type is basically, I take a function from t to a and I produce a t, and then I take a t and I give you an a. Well, that's basically the same. How do if I copy this? Remember, because of currying, that's the same as this, saying, I take a function from t to a and I give you back a function from t to a. And GHCI will confirm to me, yep, those are the same. Because I say, tell me the type of memo, and by the way, I insist that its type is this. It'll produce an error if the type isn't that. Otherwise, it tells you, yep, that's the type, all right. So, what's the point? It's just the identity function, right? Well, that's what memoization is for, so that's what we should expect. But how does it do anything interesting? If there's no mutable state, how is it that when you call this function with an int, let's say 5, and then you later call it again with the same int 5, where has it put the state where it's remembered what the result for 5 is? And the general idea, ignoring some of the details here, is that when you call memo tree on f, which for us was step, we were calling memo on step, as you can see at the top of the page, it, before returning to you a memoized function, it produces a tree where the keys are every single integer that could ever exist, and the values are the results of calling f on that integer. so that instead of ever calling your function after that, it just references the tree. It says, "Oh, I've already like stored this somewhere in my tree. Let me look it up." And because of laziness, it doesn't actually call your function on all of the things until you need it to, until the first time you call it for a specific value. Then it goes and like looks up the thunk, and the GHC runtime says, "Oh, I better force this thunk that's been sitting here for a while, and then store the result of what I got." And then the next time it goes to look in the tree for the same value, what's there is no longer a thunk, but the value that was computed. Right? That's kind of how GHC's laziness works. Is that if you have a value, not a function call, but like the actual value produced by a function call, the first time you look at it, it will actually go do some work. And any time after that, as long as it's the exact same value, the same pointer, the work that's been done is remembered, and it's just the result that was there. So memoization pre-computes your function for every possible input lazily, so that when it wants an answer, it can just look it up in the tree. Anyway, so memoization is kind of cool. That's all. So those are the two things I did for day 11. So let's see what's up with day 12. Garden groups. Why not search for the chief historian near the gardener and his massive farm? There's plenty of food, so the historians grab something to eat while they search. You're about to settle near a complex arrangement of garden plots when some elves ask if you can lend a hand. They'd like to set up fences around each region of garden plots, but they can't figure out how much fence they need to order or how much it will cost. I do have to say, I'm the very tiniest bit spoiled. I happened to see someone say that day 12 involved area. So there you go. That's all I know. They hand you a map of the garden plots. Each garden plot grows only a single type of plant and is indicated by a single letter on your map. When multiple garden plots are growing the same type of plant and are touching, horizontally or vertically, they form a region. Okay, so a plot is like a cell, I guess. Like this is a plot, and these four B's together are a region. This A is a plot, these four A's are the region. I think that's true. Multiple garden plots are growing the same type of plant and are touching, they form a region. In order to accurately calculate the cost of the fence around a single region, you need to know that region's area and perimeter. The area is the number of plots. A, B, and C are each in a region of size 4. Yes, I agree. D is in a region of size 1. E is in a region of size 3. Great. Or area, not size. Each garden plot is a square and so has 4 sides. The perimeter of a region is the number of sides in the garden plot that do not touch another plot in the same region. So, if we look up here, yeah, I mean, it's what you'd expect perimeter to be, right? There's 4 on the top, 4 on the bottom, 1 on the left, 1 on the right for this A's. C, let's see, it should be 1, 2, start at the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the same size as A. I bet B will be smaller because it's packed more efficiently into a square. Yes, B is size or has a perimeter of 8. Okay. Plants of the same types can appear in multiple separate regions, and regions can even appear within other regions. Yes, of course. Yeah, the region containing the type O plants is more complicated. Due to modern business practices, yeah, this is some way to force us to return the area and the perimeter as a single number. They've just made up some reason. We have to multiply them together. Fine. Yes, understood. So, how... How would we do this? if we had a... Suppose, first of all, that an elf helpfully gave us for a set telling us here are all the coordinates in a region, right? We don't have to do the work of finding the region R. Then a fairy is just going to tell us. Then you could compute the area of the region by the size of the set, and the perimeter by by mapping, I guess, over the set and adding up, mapping each one, each plot. You could compute how many of your 4 neighbors are not in the set that defines your region. Right? So, and that would, if you took that function mapped over each of the plots in a region, and you added them all up, that would tell you the perimeter of the region. I'm pretty sure that's true. No weird edge cases. Anytime you have a neighbor that isn't in your region, you need exactly 1 fence to that neighbor. And that's even if you have 2 cells that both have the same neighbor that's not in the region, or indeed even 4 if it's a region enclosed within yours, you still need 4 fences in that case. 1 for each of your cells that touches that cell. So I think you can just independently compute that. So if we were given a set of cells or set of coordinates describing a region, we could very easily compute the area and the perimeter of that region. So the interesting part that still remains for part 1 is indeed, how do you compute a region? Or I suppose it might also be interesting to determine that actually you don't need to compute a region. Maybe you can get the area and perimeter without ever actually explicitly computing the region. It seems unlikely, but it would be, maybe it's possible. So I think that computing a region, I guess we have we want a region to be a set of plots, and I think we want our entire, what do they call this, garden, to be turned into a set of regions. Now, it's interesting that the same letter can appear multiple times. I assume that will matter in part 2 somehow. But for the moment, we can... Are there any examples here of the same thing appearing twice? Yeah. There's C's here and C's here, and they don't touch, so they might as well, one of them might be a Q. If this were a Q, the answer to part 1 would be the same. So, I don't think it's difficult to compute all the set of regions for the garden either. The idea is I think there's multiple names for this algorithm / idea, which, one of them that I can remember at the moment is called a flood fill, where you choose a point, or flood fill in general, you start with some point, and then you just explore outwards from that point in every direction, stopping when you hit a boundary. And mark each of the cells that you found, and make sure you don't visit any cell more than once. I'm sure I've implemented flood fill in past years, maybe even in every past year, I don't remember, but it's not that complicated to implement, so let's maybe do it. Oh, do we need... Right, even a cell that doesn't, this, there is no neighbor up here, but you still need a fence there because the whole garden is implicitly fenced in. Okay. If that weren't true, that would have ruined some of my earlier assumptions / conclusions. So, right. So that's what a flood fill is. You start at some point and you explore outwards in every direction until you hit a boundary, and you stop when there's no new cells to explore that aren't over a boundary. If that only helps you find one region, but the idea, I think, is to kind of color a map, which is sort of what we're doing here. Except it's like it's not K coloring, it's N coloring, where you can just use a different color for every region. But you start with a set of unregioned points, points where you don't know the region, or a list would be fine, I guess. And you start, and then you have a set of like all the points you have labeled, or something like that. I don't know, but you choose some point arbitrarily to start flood filling from. Let's say the top left. You flood fill from there. You end up marking all these R's and taking them out of the pool of points you need to classify and put them into a set saying this is one of the regions. Or maybe you just, like, you could, I suppose, immediately compute the area and perimeter and then throw away the region, but I wouldn't be surprised if part 2 needs us to do something more with the region, so it would be nice to just turn a grid of plots into a set of regions. I think that would be nice. So you label one of them and you take them out of the pool of things that need to be done, and then you look at what remains to be done. If there's at least one thing to do, you choose one of them arbitrarily and flood fill from there. Let's say we choose II. Then we end up taking these 4 out, making them their own region, and then we say, oh, I need to arbitrarily choose somewhere else. And we would maybe start with the C, flood fill this whole area, and so on, until eventually there were no unclassified points left to classify. I think that makes sense. So flood fill is often represented as a problem using like a 2-dimensional or 3-dimensional coordinate grid. But I believe it's fundamentally a graph problem, right? The only reason this grid is interesting is because it implicitly tells us the connections between 2 points. So I think, I don't want to use data graph for this, and I don't think it has a useful function for it anyway. But I think it is sort of useful to think of this as a graph problem and not a coordinate point problem, where the basic thing that you provide is a set of nodes, let's say. The nodes will be labeled, or they'll be XY pairs as it happens, I assume. You provide a set of nodes and a function for a node telling you what other nodes it's adjacent to. And I think that's about it. Yeah. And then it will produce for you a set of all the regions. I think we can write that. Do I need any libraries for this? Do I need a map? No. I need a set, though. I was talking about sets. I'll probably want in range from data index. I often import that from data array, but we don't need an array here today, I don't think. So let's import qualified data set as S. Import data IX in range. And I think that's like all we need from there. The other thing is, let's look at a previous year or day. I think day 10 was one where we did this labeling of things, right? Yeah. So let's just borrow this again. it'll give us the bounds and a list of labeled characters, which is exactly what we want. So I guess I'm going to need... kind of annoying. I mean, it's obviously a big hammer to bring... to bring linear in just for V2, but you know what? That's the type I gave it before, and that's what I'm already bringing in a bunch of libraries. I don't need what's one more, right? So import linear V2. I think that's it. I shouldn't really need X or Y, right? Oh, I kind of do. It's actually kind of the same thing I did in day 10 as well, right? Where I got like all the directions. This here. It does seem like a nice function. So, I'm in the wrong file. Okay, so let's import linear.vector basis as well. Because really what we want, I guess, up here, neighbors takes a v2. Well, really, I mean, new a v2a, v2 of a produces a list of v2a neighbors p, sure, is plus p. Well, it's this, right? So we ask for the two basis vectors of our coordinate system, choose arbitrarily whether to use the basis or flip it backwards, and then add the result to P. So we'll use that to be one of the things that our adjacent function for our graph uses. It'll refer to neighbors, getting all the adjacent position points. And then it will furthermore look up, hey, is this point in bounds? And also, is it the same, does it have the same character there? Oh, it's a little bit sad, actually, that I'm going to have to. I would need a map if I wanted to do it this way, or indeed an array, because given the coordinates of a point, I can tell you the coordinates of its neighbors, but I can't tell you what type of plant is being grown there, what character is there. So I saw in the functional programming Discord someone, and I think it was Melissa again, had done something for one of the days that I used an array. I don't remember which one. That was clever, and I didn't really read it carefully enough to understand how it worked. But rather, oh, it was the trailhead finding one. I remember that. Was that day 10? Yes, it was. this person, who I think was Melissa, so I'll say she, but maybe I'm misremembering. It could have been someone else. Rather than building an array of the grid and looking things up by coordinates, made like, I think, for derived arrays from the input that were like shifted up or down or left or right by 1, and then zipped them together so that every coordinate had like, I don't know, how would you do that? It doesn't make sense. You can't zip them together because they're different sizes, so it must have been something else. Let me see if I can find that quickly. Actually, I don't have to do it quickly. I can just pause the video and get back to you when I find it. Okay, so I found it, and the answer to my question about, well, how do you zip things together if they're different sizes, is that this solution does, like, it zips them together but adds padding around into the cells that are too short in a way that, like, it adds a neutral padding element, which, you know, we could do here. We could add a boundary around the grid. Well, we couldn't really, because then we would end up finding the region. And anyway, like, I think I'm not going to do it that way. I'm gonna define the array and compute it. You know, just find regions by looking through the array, I guess. I'm not super thrilled about it. Oh well. At least it'll be an immutable array. There's no reason we're going to have to modify anything in it. And it's like, I don't know. It's usually easier to use maps in Haskell than it is to use arrays. And I use arrays anyway because a couple years ago I couldn't figure out how to do it, and I'm still like making sure that I stay on top of how to use arrays because I don't use Haskell often enough to remember it so easily. So whether, I mean, it would probably be easier to use an int map here. Or just a map. But I'm going to use an array just to make sure, like, I stay in practice, and it is actually the efficient thing to do, which is sort of nice. And I think we could use a U array, right, if we wanted to, because what we're storing is basically an unboxed char. I think that makes sense. So that's something I don't have occasion to do very often. Maybe that can be the thing that I'm practicing sort of today. A U array, an IIV, more efficient, but it's strict. Cool. So that's no problem. All right. So I think I want my input to be a U array. Let's actually type garden as a U array. Of coord and char, I guess. So let's maybe define prepare here. Because I think prepare is basically just label grid and then make an array out of it, right? Pair of input is... Actually, how do you even define a U array? Is it you also still just call array, or is there a different thing? Data array base. Don't give me that one. Give me the one in data array unboxed. Oh, is it not in the data array package? I guess it, or module? I guess it isn't. Interesting. Okay. So it's actually in this module. And it just uses the iArray interface, right? Which it re-exports. So yeah, we can call array. Okay, great. As we call a array bounds plots, where, I mean, this is simple. Bounds plots equals label grid of input. Does this type check so far? No, because I haven't put array in my Cabal file. That's true. And I'll have to restart GHCI again. A.uarray. You're right. Oh, hang on. My Cabal file still has... At least when I'm editing the... I'm not going to delete the stupid carriage return out of every Cabal file, but at least when I'm editing it, I should do that. Good. So we're not using sets or in range. Oh, and actually, I can take in range from array since I am actually importing it after all. Okay, so we've labeled our input. And now what we would perhaps want is regions, maybe? So do we want regions, or do we want just a general flood filling function that we will then call in a function using named regions? I think it's nice to have a single flood fill function. What is it? I know there's another name for flood fill. Flood fill alternate names. There's a, because I actually learned it by another name first, I thought. But then someone was like, "Oh, I just did a flood fill," and I was like, "What is that?" And it was like just the thing I did. So it's called a, also called a seed fill. It says here on Wikipedia. I never heard of that name. Yeah, I'm not sure. I swear there was some other name I knew this by. But I guess it just doesn't exist. Okay. So flood fill, provided, let's see, I don't need any constraints, I think. I'm taking functions for all the interesting things. So flood fill takes it's kind of annoying that it wants to take a function named neighbors, and I don't want that to be the same as this neighbors function. Flood fill, let's say it takes edges. That's a good one. Oh, but all right, I'm not even naming it here. I'll name it inside, but so flood fill takes and actually it does need at least ord a, doesn't it? Ord n for the node type, because it has to maintain a set of all the nodes it's visited. It takes a function from n to list of n. That's the neighbors function, or edges. Maybe we should even call this V to evoke vertex. And it takes an initial V to start the search at, and it produces a set of V. I think that's true. So flood fill of edges V? Start? Call it S. It would be capital S in math, but you're not allowed in Haskell, so we use a lowercase s. Is go of, well, so we need to maintain a scene set, a visited set. Oh, does this want to use state? Or does it not have to? Because, like, in principle, you want to use, like, a priority set, or just a set of nodes you still want to work on, right? Nodes you've seen and nodes, like a boundary, a frontier, they would call it, I think, in graph theory. Like, yeah. So, I mean, I could go look up how you do this. I do have the flood fill Wikipedia entry article open. Thanks, since I was looking. Actually, I closed the tab, I guess, but I could find it pretty quickly. You need a scene set and a frontier set, basically, right? I think having them both be sets makes sense. And every time you visit an actual node, you check to see if it's already in the scene set, and if so, you just keep going with the same scene set and pull a new thing out of the frontier. And if it hasn't been seen, you add it to the scene set and add to the frontier everything that it is a neighbor of. That makes sense. So let's say we start with an empty scene set, and the singleton node S in our frontier, the node we want to explore. Go of scene and E? No, V. The new, no, right, we're calling it a frontier. If the frontier is empty, then it's just scene. We're done exploring. Oh, so shouldn't I then... No, I should do more. Is there... In data set, there should be some function that lets me get a view of, like... Yeah. So I want to remove an arbitrary item, but I guess I'm stuck. Like, all I can really do is remove min or max. Which is probably good anyway for the set because it involves the least rebalancing, question mark. So I want... Well, okay, we'll use min view. Case min view frontier of nothing. It's just scene. We have completely emptied the frontier. There's nowhere left to explore. We found all the nodes. Just, it returns a pair of a selected node and this frontier without that node. So VF, if S member, and what order does member take its functions in, its arguments in? Takes the key and then the set, or the element and then the set. S member, I guess people often use it infix, is that true? Yeah, it's like elem. Okay, I should remember that. Member is like elem. Okay, so if V is a member of scene, then go VE scene F. No new work to do. We've already visited and explored this node. Otherwise, is go of S insert V scene. We are exploring this node now, and also S from list edges V. Let's actually do this in the other order. F plus all the edges. So in this way, any edge that's already in our frontier... This is a little bit annoying, because when something is still on our frontier, and we happen to explore another of the nodes adjacent to it, we'll say, I won't bother, unioning that in with the existing frontier. It won't do anything. It won't get added. But then when we've explored a node, it's no longer in the frontier, and then we explore something else adjacent to it, we'll say, let me put those all on the frontier. Also, we have to do more than this. We have to say, if we've seen the node, just continue. Oh, yeah, that should happen... Wait. I guess we're already doing that here, right? Because Go doesn't take as argument a single node ever. Neither of the two arguments are a node. There's the frontier. So we have to decide what to do, break apart the frontier. If it's empty, we quit. If we've seen the node, we stop. We skip it. We haven't seen the node. Yeah, so in principle, I think what we should do is subtract from this from list anything that's already in our scene list. How efficient is like set difference? Okay, what the hell? Oh, right here. So difference. So n divided by m, where m is the smaller of the two sets. N divided by, okay, so we'll assume that n is much larger than m, in which case it's basically m log. It's doing a linear operation on the smaller set and a logarithmic operation on the larger set. So it shouldn't be too bad when you have like 4 items. It's basically just doing 4 lookups, roughly, I imagine. Yeah, I mean, it's going to be a reasonable savings to just make sure we don't put stuff into our frontier list that's already on the scene list if we can avoid it. So let's make sure to do that. Let's actually say new frontier, space, the final frontier, where... Why am I allowed to put it here? Shouldn't it be... I guess this... What's the difference between putting it here and here? Very strange. Anyway, I think those are the same, but this is going to be in scope for both of these cases, but it'll only be used for the middle case, so it doesn't really cost us anything. New frontier is this difference seen. So, or oh no, we should do this a little bit better. Don't add this to f and then subtract scene, because that's going to be large. What I want is f and then add to f the edges of v minus the ones we've already seen. So I think we could actually drop all the parentheses there. What do you think? Does this compile? No. Of course. I always forget this. I always forget you have to use arrows when you do a case match. I remember that, but I forget that that's true even if you use a guard. I'm so used to putting equal signs after guards. I don't know why. So that's probably why it was letting me, put this where in a stupid place. It wasn't parsing correctly. Now these are the only two places it wants to let me put it. And I'm not even sure this one makes sense, but okay, fine. Actually, why wouldn't you let me put it here? Oh, because, it's another where. Okay, sure. So here's where I want it. Good. This compiles. So we could test this very quickly if we said flood fill of 1? No, wait, order, it needs the order first. So const 1, 2. So starting from node 2, and assuming that every node is connected exactly to the node 1, do a flood fill. That should tell me it should be a set of 1 and 2, right? Yes, correct. And if I said, actually every node is only connected to 2, it gives me back only 2. Now this is not exactly a proof that flood fill is correct. It's a very simple function. So but I mean it's close. It doesn't infinite loop or anything. What if we said every node is connected only to the opposite of itself? We get back minus 2, too. I mean, this seems pretty good. What if we said does this make sense? No. What I want is to say I guess I'll just do it in a non-fancy way. So n is connected to both n div 2 and minus n. Is that legal? Like, would that produce a good answer, do you think? 5 connects to -5. Oh, what do you get if you divide? -5 div 2? It's -2. So I think this should basically give us every number except maybe 4? If I start at 5, whoops, because there's no way to get to 5 or 3 for that matter. And it'll give us the positives and negatives of those. You can get to 3. That's a little bit surprising. I wonder why. But okay, I mean, this is basically what I wanted. How do you get to 3? So 5 maps to -5, of course, and also 2, right? 5 div 2, that's 2. And -5 div 2 is -2. So how do either of those ever find their way to 3 is what I want to know. Obviously it must happen, because I don't think flood fill could be wrong in this way. That's very strange. What if I said map div 2 of this? One of them goes to -3. Am I stupid? Which one? -5 goes to -3. Okay, there must be something wrong with the way that I'm like. Oh, I see. It's doing this when I ask it what -5 div 2 is. If I did this, it would say -3. Okay, great. So 5 goes to -5, which goes to -3, which goes to 3. That's how the 3's get in there. Great. I'm reasonably convinced that flood fill is working now. So part 1, we could probably start writing then. Now, we could also say, if we wanted, that the input shouldn't actually be an array, but it should be the set of regions. Because we'll need that for part 1 and part 2. But you never know, part 2 might change how regions are defined. It might say, oh, actually, diagonals are allowed to connect regions, but you still only have to build fences orthogonally or something like that, right? So I think I want the input to be just what's actually in my input file, and then like anything that I do on that will be part of part 1 or part 2. So let's then define the area, which takes a set of A and produces an int. Area is just, oh god, it's size or length? I hate these libraries. It's size, okay. Perimeter is more interesting. We talked about it at the beginning, but I've forgotten. Right. So to compute the perimeter, you no longer need the original array, right? You can just say anything that's adjacent to this node but isn't in the region must have been a different thing. So we can just say perimeter takes a set of do I want to take a v2 here? Or, I mean, I guess so, right? v2 of, I mean, I guess we could be more generic, take any number, produces an int. Perimeter of R is the sum of mapping? Is there some reason, something I should do that's better than this? I don't think so. Of a coordinate is length filter, we'll actually call this a region. We have not member, is that a thing, right? Yeah. Filter of the is that, I guess it's just this. We don't even need to name P. So I think this makes sense. Find the neighbors of a node. For each one that's not a member of the region, count the ones that aren't neighbors of the region. So that makes sense. Doesn't compile though. A list of v2 and a set of v2. Oh, right. Map fences need, map expects a list, and I'm giving it. I think I can just, I mean, I'll just do this. Convert it to a list. No? Oh, you're right. We do need ORDA. Because we have a set and we're doing stuff to it. Great. So now we can say, what is the perimeter of the list v2 0 0. It's a region of size 1. Its perimeter should be 4. I don't want all those stupid type errors. So give me, say this is a set of v2 of int. Fine. And if we were to add then v2 of 0, 1, this is like a 2x1 domino. Its perimeter is 6. If we added v2 of 1, 0, what is that? That's 8, isn't it? The top is 2, the left is 2. The right is 1 and the bottom is 1, but then there's another little jigsaw size 2 cut out of it. Yeah. And so when we add 1, 1, it shouldn't change at all. v2, 1, 1. Great. Okay, so perimeter's right. I mean, it's not a proof, but I think it is. So we just need to, we have a way to find the area and perimeter of a region. We have a way to label one, to find one region. Now we just need to write a function that finds all the regions and then calls area and perimeter on all of them. Int part 1 is sum.map fence cost all regions where fence cost is just lift a2 plus of area and perimeter. So add up the area and the perimeter of the input. And all regions is the interesting part. So all regions of G for garden / grid is go of what exactly? So I need a set of all the plots that have not yet been assigned a region, which is just to take the array and convert it. I think it might just be s.fromList of a.assocs of G, because yeah, that makes sense. Because the assocs will be a pair, each assoc will be a pair of coordinate and the character that's there. This go has to be part of all regions because it needs access to G. It can't be a top level where. Go of pending equals case min view pending of nothing. If there is nothing left to assign, we just return empty. If it's just, oh, am I using parentheses I don't need the other time? No, okay. Just some arbitrary element, which will be coord plant. It's what's growing there. Label, something like that. And then pending prime, basically. Is flood fill what's a word for their flood fill? Same? They're the same if they're connected? Starting from just the coord. We won't give it the plant. Flood fill is just taking, in this case, I mean, it could take anything, but we're going to give flood fill just the coordinates, because that's all we really want back anyway. Cons to actually, we can't quite do that. New region, cons to go of pending difference. Oh, I don't want difference, do I? I want to like remove all. Is there a... Because I don't actually have the values. Oh. That's kind of lame. Since I don't have the value, I can't actually remove the item from the set. Okay, well maybe I will actually give... This is probably better anyway. I can give it... Right, so... Pending is a set of the entries in the array. And I'm returning all regions. I'm calling fence cost on each. So I actually need, at this point, to throw away the plant part of it, don't I? Like so. If we assume we're returning a pair from coordinate to the plant type, we need to throw away the plant type. Okay, fine. Is there actually a more sensible way besides difference to delete? No, delete is the only delete function. Filter? No, I don't want any of that. Generalize, alter F is a very powerful function. I've only used it once in my life. It's really cool if you have an excuse to, but we don't have one today. I don't think I want to fold. Yeah, I guess I do just want difference. Okay, that's fine. So compute a new region, and then difference that from the pending set, and then recur, but add the new region to the list of results. Where, and we have some wheres to do here. Actually, do I need the coordinate and the plant here? I think so. So actually we can just do... Well, this is kind of funny. I don't actually need min view because I don't really need pending, like pending prime. You can use it here. It'll be slightly faster because we'll have already deleted one of the elements. I guess that's fine. Plot, we'll say here, where new region equals flood fill connected coordinate. I guess it's just plot, right? and connected actually, yeah, this makes sense. Connected coord P is I hate this part. Let's see. Do? It's never on start with a do. Coord prime from neighbors of coord. Guard. This would be easier. I just hate that list comprehensions make you write stuff backwards. I really don't like doing it. So I always do monad comprehension, and then I have to import guard because they're implicitly in scope for list comprehensions and not for any other monadic thing. Control monad guard. Okay. Guard that in range oh, wait a minute. I haven't even my input is an array. Okay, I haven't extracted the bounds yet, but I can do that because I have G in scope. So let's see. Inbounds is in range of G. Guard that coord prime is inbounds. Guard furthermore that actually, does an array have like a lookup that returns a maybe? It does actually. So I shouldn't, this is stupid, I shouldn't do this at all. I do need guard, but I can say, let's say P prime is from maybe to list of G lookup coord prime. And then we can just say guard that P equals P prime. And then return coordinate if all of that was true. This is not the prettiest thing anyone has ever written. But I think it like sort of makes sense. How far am I away from compiling, would you say? As always, at least once. I did claim I remember to use arrows when I'm not doing a case or a guard, but this time I didn't even remember it in that case. Ah, come back. Okay, somewhere I did not convert. Okay, so then maybe to list isn't in scope. That's easy to fix. And then a million type errors. Oh, is all regions, did I make that? It's not a function, it's a value. No, it's not. It takes an input. Okay. Oh, whoops. That's at least one mistake I made. I used A's lookup operator, but I should have used the one that returns adjust. Okay, that's one fewer type error. What is this? All regions. It wants an array. Oh, you're right. I have to break up. I didn't even build the array. I forgot. Make array of bounds. Actually, I think it's just uncurry of actually array. Like that. Okay, it's more wrong now, but maybe that was okay. Maybe what I did was... Oh god, why is it saying A5 and A6? Where is it getting these mad types from? So, okay, let's start labeling some things myself. My intention is that all regions is a function from a uarray of v2 int containing chars to a set of pairs of v2 int and char. Does that help at all? Oops. Maybe. Okay, so... Oh, not a set. A list of set, in fact, right? So I'm producing a list of sets. That makes sense. Okay, try again. I keep hitting the wrong button to scroll up. Okay, that's good. We're down to just 2 type errors now. 3? Nope, I'm wrong. But they're a little bit smaller, and they have a lot less crazy inferred types. Here you expected a set of pairs, and instead you have a pair of a set and something. What is the type of array again? Takes the bounds and a list of pairs. And is that not what we have from label grid? These are the bounds. This is the list of pairs. That makes sense. Wait, is fence cost crazy? What is... All regions is returning a set. Map fence cost is taking a set... So fence cost is taking a set of... Oh, that's silly. Isn't it? No. It's getting a set of pairs of things. Oh yeah, first is crazy. First doesn't belong there. I have to like fmap first or something. Because it's getting a set of pair of int and char, but it only really wants a set of pair of int, or v2 of int. So I think actually I want fmap first here. Now we genuinely are down to 2 errors. Okay, good. Progress. This would be easier if I had like an IDE that told me things were wrong as I was writing them. Maybe? I'm not sure. Or could tell me what type it inferred for a function. Couldn't match type. Pair of v2 of int, list of v2 of int char with a u array. Well, okay, why not? Where is it that you expected this to happen? Uncurry a.array. Well, uncurry a.array should expect. Why are you expecting a u array? So you found a function that turns an input. Oh, wait a minute. What is my input exactly? I've already made the array here. Okay, I got confused somehow. I think I can do that. I was thinking this was my the result of label grid, but it's not. It's the result of prepare. But I've already built the array. Okay. Progress? Question mark? Yes. You expected a pair of ints, but instead there was a pair of int and char in flood fill. Connected. So somewhere I forgot to remove a char, or I forgot to add one or something. So flood fill of connected. Oh, well, that makes sense. I'm returning just the coordinate, but flood fill is operating on pairs of coordinates here. So we should really say p prime, which of course is the same as p. Oh, yeah, that's true. You can't call... Right. Set isn't a functor. I'm sure there's... I can just call s.map. And... this risks, in some cases, like the set changing size, which might be what you want. It's not a risk. It's just something to be aware of, right? If you have a set of things and you map a function over that set of things, if the map function is not injective, yes, injective, then that is if it maps 2 input elements to the same output element, you might get a smaller set out than you put in. Sometimes that's what you want. In this case, it doesn't matter because that'll never happen. I don't ever have sets where, like, I have 2 different plants at the same coordinate. So I can just do that. Okay. What would happen if I ran main? 36,576. Seems like it could be plausible. Is there a way we could do a quick... I could just put it in the website, but I feel bad anytime I type something in and it's wrong. So let's think briefly. Is this number plausible? Our grid is size 140 by 140. So we know that the area of that is what? 14 times 14 is... Is it 196? And then times 100? It's like 19,600, is that right? guess. So the total area of all the... Oh yeah, this is definitely wrong, and I know why. Good. I'm glad I did a sanity check. The total area of the entire grid is 19,600. And each plot belongs to exactly one region. So this would be correct only if regions, on average, had a perimeter of about 2, which is impossible. Every region is larger than that. And the issue is that I am adding rather than multiplying the perimeter and the area here. So let's try that again. No. That's a much bigger number. What is the square root of this? 1166. Is that even... Why did I ask that question? I'm not sure. Well, what is this? Maybe a better question would be, what is this divided by 19,600? So this would be a correct answer if the average region had a perimeter of 69, which, I don't know, that seems plausible. So let's try putting this number in. That's the right answer. I'm glad that my first answer was correct because, I mean, it almost wasn't, right? It's a little embarrassing to turn in your homework and to be told, no, this answer is completely wrong and not even plausible. You didn't even think. You just typed in what the computer gave you. Where am I? There we go. I don't have any compiler warnings, right? Correct. Okay, great. Day 12, part 1. All right, let's see what's going on with part 2. Fortunately, the elves are trying to order so much fence they qualify for a bulk discount. Under the bulk discount, instead of using the perimeter to calculate the price, you need to use the number of sides each region has. Each straight section of fence counts as a side regardless of how long. I see. Okay. That's fine. I haven't worked out yet how to compute the number of sides, but I know one thing I have to do is lift out a bunch of this code from part 1, and indeed we do just want the same regions for part 2 that we did for part 1. And I think it really is just lifting out this all regions function, right? All regions isn't closing over anything. So it can just become a top-level function as easy as pie. Let's make sure we still get the right answer. 136, 1494. Yes, that's correct. Okay. So that's easy enough. So part 2 is very similar. It's sum map fence cost all regions. And I mean, we could extract out a function called solve that just takes like perimeter as an argument. I think map first here is kind of gross, isn't it? guess it's fine. Where fence cost is lift A2 times area and num sides. So this compiles, but of course we haven't defined num sides yet. So how would you determine a side? A side, like, I think, how did I do perimeter? We're mapping over the region and producing something. I think it's basically the same idea. Well, except totally different. Because you can't just map a function over each plot and then sum the results. There's some interaction between plots here. I think a side is defined by an x coordinate or a y coordinate, a pair, ordered pair, of either two x coordinates or two y coordinates. So if we're looking at a cell xy, and we look to the left, i.e. in the minus x direction, if that cell is not in the region, no, this is wrong. What I'm coming up with is wrong, but it's maybe an idea in the right direction. Then my idea, which I now believe is wrong, but let me finish saying it, is that x comma x minus 1, that's a pair that kind of says, well, we need a side in between these two. And if we then went up a cell to, like, let's say x comma y minus 1, and we looked to the left of that, and it was also not in the region, then we would say, okay, well, there's also a pair x comma x minus 1, and those two kind of, since they're part of the same side, and they have the same representative pair, so we could just, for each cell in the region, compute these pairs for each cell they aren't, each of their neighbor cells that isn't part of the current region, and then count up how many such pairs there are. But that's not good enough. Because you can have a situation like, and there are examples of this in the input. A situation like this, thank you, an E-shaped region, full of type E plants, how considerate. The issue is that this E, looking to the right, will say, I need a wall to the right of this X position. And this E, looking to the right, will say, I need a wall to the right of this X position also. And the logic of what I was saying earlier would be, and you can deduplicate those. They're walls at the same X position, and therefore they're the same wall. But that's not true. There's this in between them, where, like, actually, this... So how do you... I don't know. How do you determine where all the sides are? I mean, something I don't like the idea of doing, but that you could do, I think. No, even this is too tricky. You could choose a point to start from and kind of follow the left-hand rule of walking through a maze. Let's say we start in the top left corner facing right. We stick out our left hand, which will be along the top of this E area, and we kind of walk, tracing out the path that our hand makes. And whenever we have to turn, because we would otherwise be walking outside of the region, then that is a side, right? Our left hand would go along here, and then along here, and then here. And each of those turns would be a side. And that's specifically a 90-degree turn, right? Because when we get to this cell, we'd be facing east, and so we'd say, oh, there's a wall, there's something in front of me, so we need to turn to face south, and that makes a new side, this one. Then while facing south, you would say, oh, there's still something in front of me, I better turn right. And now our left hand, that's another side, i.e. this one, and then our left hand goes along the bottom here. And you would even have to turn... But like this... I don't think this idea really works. Because you'd never end up visiting... This is a perfect example. If you just started here and followed the left-hand rule, you would make 4 turns, and you'd say, okay, I'm done. There are 4 sides, but that's not true. There's this internal area. And it doesn't want to know how many sides there are in the whole garden, right? It wants to know the per region price. So like this wall in between X and E is going to count as a side for each of them, which is kind of interesting. So you can't do some global computation of like, oh, let's just compute how many sides there are in the whole graph. That doesn't make any sense. That's not what they want. I don't know. I'm not very smart at this. I feel like this is not in my wheelhouse of figuring out like how many sides are in a figure. My whole data structure isn't really about this. What is a side? Well, what was wrong with my original idea of saying that you need... Yeah, maybe there is something to that idea. Is saying that there's, like, to the left of this spine of the E, each of these E cells can detect that there should be a wall to the left of it. And it can say, there's a wall between this x-coordinate and the x-coordinate to the left of it. And two of the 5 E's will also say there should be one to the east of me. So what's different about those two scenarios is that there is there is this kind of this is kind of a non-convex. I don't think convex is obviously wrong, but maybe it's sort of close to right. There's this protrusion into what would otherwise be a single side along the inside of this E. The right side of the spine. So maybe you could collect the fact that these two E's think there should be something to the right of them, but also somehow get the information that they shouldn't be part of the same side. Because I don't know. You can't just say because there's an E in between them, because the same thing would be true if this E were one bit higher, like if there were just another row of X's, like if this chunk of X's were too tall. And, also this E doesn't have to be a straight line. The middle of this E could curve around and do this, but it would still be dividing these. So maybe what I want to do is for each cell in the grid, have it produce a list or a set or something of the places it thinks a wall has to go. And I think that list should be unique, in fact, right? It could be a set across the entire grid. I don't know if there's any point in making it a set, but it could be. Because there'll never be any two cells that agree that both put a wall in the same place. Because that could only happen if those two shared that one place as a boundary, and then they would decide not to put a wall there, because they're the same region. So, suppose we produced all of those, and then, we group up all the horizontal walls that share a y-coordinate, i.e. they're at the same height and they're horizontal walls, and we split them into groups. We sort them, let's say, even within each height. And you group them by, do they differ by an x position of exactly 1? If so, they're part of the same group. If not, they're part of different groups. And then do the same for vertical walls. We would group those. A vertical wall would be like this. So we group those by their x-coordinate, and then see if they differ by just 1 in the y direction. And when they differ by more than 1, we emit a new line. Or we consider that a different group. I think that idea makes sense. I think that would give us the right answer. The details of implementing it are not yet completely clear to me, but I think that's enough to get started. I think I've finally got an idea of something that could work if I implemented it right. How much can I reuse from perimeter? Yeah, I mean, is that really what perimeter fences needed is doing? It kind of is, right? I have length composed with filter, not member region, composed with neighbors. But if I just threw away the length part, almost. Okay, I think trying to reuse perimeter is sort of needlessly miserly, and I should just write a new function that's like it but different. Oh, what if... Oh, what about... Okay, hang on. There's something I'm not sure about yet. Let's read the problem statement some more. I think this is the situation I wanted to ask about, so I'm glad it's here. So, like, what... You're... In between these A's and B's, you're drawing a line. And you're also drawing a line over here. Is that the same side, or is that two different sides? Be especially careful in counting this fence around regions like the one full of type A plants. Each section of a fence has an inside and an outside. So the fence does not connect across the middle of the region, where they would touch diagonally. Okay, so that's what I was worried about. So it's important when adding a fence to our list of needed fences that we not only know which two cells it's between, i.e. here and here, but also which of those two cells is part of our region and which is part of the offending neighbor region. So I want to put our region first in the list so that this says I need a fence between 3,3 and 4,3. And this one says I need a fence between 4,3 and 3,3. Or 4,3, 4,4 and 3,4 using the y-x coordinate system. I think that works. We're basically... By doing that, I'm saying you can never have a single side produced by two cells that are at different heights. That's true, right? Yes. Okay. So let's try that for starters, or let's start trying that anyway. Kind of weird. Fences needed is like what I want to name this new function. So we have a sides function which, provided A is ORed and num, takes a set of v2a and produces an... I mean, I guess this... If we're going to write the entire sides function all in one go, then this can just return an int. I guess that's fine. sides of a region is something. It's horrible. I'm at a little bit of a loss of how to... So, like, okay, first of all, I want to, like, do this-ish. So let's let this happen. Where fences is this, and fences needed is this. So fences... No, this isn't actually what I want. Okay, fences needed of a position is to filter... Actually, I guess it's... this? So compute all the neighbors of P. Keep only the ones that aren't part of your region. And then turn each of those into a tuple, starting with the P that is in the region, and then the position that's not in the region. So now we've computed each of the fences we need to build. And these are unique, as we talked about. There's no way any two positions, any two plots, could want to place the same fence. So now I kind of want to I wanna I want to find the ones where the wall being defined is horizontal and group them together by their shared y coordinate. And the ones that are vertical, group them by their shared x coordinate. There's a function that's called swap, right? I imported, huh? Okay. So swap takes a tuple and swaps it around. So the cute thing is, is something cute? If I have a pair of 2 points that are adjacent, if their x coordinates are the same, or if their first coordinates are the same, let's say, because I don't want to have to think about whether I'm doing, like I am doing these y major, but like it shouldn't matter. If their first coordinate is the same, then their second coordinates will differ by 1, of course. And so I kind of want to group up all the ones whose first coordinates are the same And then I can do a cute little trick, I think, where rather than like grouping up the ones whose second coordinates are the same and then doing some special handling in each of those where I like work on whichever coordinate wasn't the same, I can just swap all of the tuples. Like if they weren't... If... Take all the ones that had different first coordinates, those must have the same second coordinates, and so I can call swap on each of them, and then suddenly they'll have the same first coordinate. So if I build two lists, maps, I guess. One of them will have been swapped, and the other won't. But they'll both have the same, in each map, they'll all have the same first coordinate. And so I can just write a function that assumes every... Yeah. Okay, I think this makes some sense. It's not, like, easy. I'm not there yet, but... There's got to be some easier way to do this. But I don't know what it is, and I finally found a way that seems like it should work, so... So fences is a list of pair. Actually, I want to do... Can cat map fences needed? Because each cell will define up to one place that it needs a fence. And once it's done that, I don't really care which cell said it needs a fence there. So I can just merge all of the lists returned by fences needed to a single list, and then do some processing on that. So if I think I want to write a function that groups the result of fences. What do we have in data list? I don't think it's really what I want, but let's check. Accumulating maps? Oh, I see. Not a map as in data map, but as in the map function. I don't want that. So, like, the group function is not really what I want. I think I want to put all this stuff into a map. I want two maps. One for the horizontal walls and one for the vertical walls. And each map will contain a sorted list. Or anyway, a list, and then I'll do sorting when I'm ready to walk over them, I guess. Or the value will be, the key of the map will be the shared coordinate they have. The value will be a list of all the distinct coordinates they have. I'll sort those and then group them by whether they differ by one. And I don't know the way... Like, none of these are quite... There's not like a function that I know of in data list that says, you know, split on whether these two are like that gives you two adjacent elements and lets you do something interesting, like look at them both or something. I don't know. You can zip a list with its tails to get lists of pairs, but that's not what I want. Okay. Yeah, you can just, I think, write a simple recursive function. That consumes the list. So anyway, we're not there yet. Right. So I want to. Where I want to do something with the result of fences. Like maybe I want to get a tuple of the two maps that I'm building. Horiz and vert equals align fences like that. Align is gonna be exciting. A line of empty is just an empty tuple. No, that doesn't make sense. Excuse me. Actually, is a map a monoid? I'm not even sure. Also, I don't even have map supported yet, do I? But is a map a tuple? Data map strict. No, not that one. This one. Oh, it is. A map is a monoid if its keys are ordered. Empty should be the empty map. Yeah, of course it is. I don't know what I was thinking. Making it an applicative is more interesting and maybe impossible, right? You can do it in a weird way that doesn't really obey the laws, is my recollection. Okay, yeah, maps are not applicative. But that's not what I want right now. I just want them to be monoids. A line of P prime cons to F's is if it's a little annoying. Okay, let's just destructure these here, I guess. V2 of Y1, X1, and V2 of Y2, X2. If, let's put a space here, it feels better. If Y1 equals Y2, then it's let's see, if the y coordinates are equal of these two, they're at the same height, so it's a horizontal wall. So it's M insert of their shared y coordinate, which we'll call y1, wait, is this wrong? I've forgotten how this shit works. So the left coordinate is my cell. X1, y1, those are our cell. Y2, X2 are the other one. So yeah, so I'm inserting with y. With y1 as the key, and I think I just need x1. I don't need x2 for anything, right? Because I know... Oh, wait, do I? No, because we... Oh, actually, it's different. I think. I only need x2? No, I need... The idea was they have a shared y coordinate, which means they're at the same height. I had the idea that I would put these into a map, and obviously they can go in a map that of like things that all have the same y. That's fine, I think. Because wait a minute, so this is a horizontal. These two cells are adjacent horizontally, which means we're making a vertical wall. Oh. Which means I'm going to have to look at other vertical walls with the same x coordinate? Right? And determine whether there's an unbroken, like whether their y's are adjacent, in which case it's the same wall, or different, in which case it's a different wall. So I want to put this... into a list where I think I actually have to use yeah. Okay, I do need all of these numbers. Good. Because it seems like I should. So I want a map keyed by x1 and x2. Saying there's a wall in between our cell x1 and their cell x2, and it's at height y1. Otherwise is h's and m insert y1, y2. Oh, I need, oh yeah, that's right. X1 v's. And actually, we should be a little more careful here. Don't write otherwise. Instead, write x1 equals x2. Close this. Otherwise equals error of show, I don't know. Like, this sucks, man. This shouldn't trigger because they should have the same y or the same x, because that's how fences needed works. It only looks at adjacent neighbors. We'll just show this. I don't expect this to ever happen. Okay, so I think this is the idea. When we're aligning... Oh, and this is... I see. This whole thing is is a fold map. Where we're accumulating a tuple, and at each step, yeah. Okay, let's write it that way. It's a little bit more clear what. Fold map align. So now we don't have to do the pattern matching anymore. And I hadn't even finished because I was going to have to write h's and v's, but now I don't have to. It'll just implicitly happen from align of a pair. We're not going to work with a list anymore. We don't have to call m insert. We can say m singleton. Empty. Empty and m singleton. So the idea is, fold map is a function that if you can take an element of a list and produce some monoid from it, fold map will call that function on each element of the list and combine all of the resulting monoids using the monoid append function. And in this example, we wish to accumulate a tuple of two maps. A tuple is a monoid if each of its component parts is also a monoid, where, like, to compose, like, here, we can even write it down. We can write it out here, instance monoid A, B. I mean, I could just look this up, I guess, in GHCI, but if A and B are both monoids, then the pair AB is a monoid where... Why doesn't it want to insert this for me? Is my file not parsed right now? I don't know. Anyway, there should be... Oh, because normally you don't write it like that. You write it like this. Where? There we go. Empty is just empty, and AB combined with XY is AX, and actually it would be much clearer to write it this way. AX and BY. It's to say A joins with B and X joins with Y. So this is what a monoid, how a pair is a monoid. They call this pointwise, looking at the 2 points of, I don't know why they're called that, but the 2 halves of the monoid each independently accumulate. And so if you can, for each point, I can produce some monoid, or a value from the set of pairs of maps, And fold map will take care of combining all of these for me and mapping over the list. So if they have the same y coordinate, we put them into a map paired by x1, x2. Keyed by x1, x2. That is going to be the place where in between our x1 and their x2, we had to put a wall at height y. And the nice thing is, actually, that we no longer even really care about which one is ordered by X and which by Y. We're going to throw away the keys, which sounds like we're locking someone up for life, but I just mean I don't care about the keys in the map anymore. The point of this whole operation was kind of a weird group by. So I'm going to call some function over the horizontal lines and the vertical lines, and I guess add them up? I don't even know if I made horizon vert. Are they backwards? I don't know. This is two different x coordinates, the same y. Yes, this is a horizontal. Okay, fine. Cool. So now I have a list of all the walls. Well, I have a pair of maps of walls grouped by what cells they're in between, kind of. So I think I was going to define a function called sides, but that's what I'm in the middle of. Darn. What do I don't know what to call this function. I want a function that takes one of these maps and produces a number. Well, no, I don't even want that. I want a function that takes a value out of one of these maps and produces a number. So let's say runs, number of runs. Runs. I don't know. I feel like runs is more in line with how Haskell names things. Runs. Maybe I should give types to some of these functions, huh? This one is a function from, assuming that A is ordered, and I mean, why don't I just say int? I'm just going to define 3 of the things that an int cares about. Like, it has to be orderable, and also it has to be a number, and like, it's just silly. Runs takes a list of int and produces a single int. Oh, hang on. Problem here is that actually this wouldn't compile as it is so far. In fact, let's do a quick check. How many reasons are there that this code doesn't compile right now? Oh, well, yeah, you can't read find monoid right now. I was just doing that for fun. Give me a break. Only one. Oh, and that's just because, like, okay, we'll unlock the more advanced errors now. Couldn't deduce show A from a line? Oh my god. What? Yes, because I haven't said this takes ints. Ugh. Fine. I should have just used int to begin with. Wait! This shouldn't compile. Should it? Oh, I see. I think. Fences is... What do you get? What's the monoid instance for... Oh, does it just throw stuff away? I bet it does. What does the monoid instance for maps do? Calls unions. That's not what I want. I hate you. Shoot, maybe I can't use fold map. I want union with emappend. I don't want union. Man. Okay. Well, I guess we can recover this. By producing a pair of lists instead of a pair of maps. Oh, although, hang on. This is fine. It is fine that they do union here because there won't be any duplicates. Right. Okay, great. I was thinking that I was incurring a monoid constraint on Y1 because when I merge the maps, it would emappend Y1 with the other Ys in the same key. But it doesn't do that. If it finds a conflict, it just deletes. Wait. Oh yeah, that's terrible. I need a list of the results. Right. Okay, so all right. Yeah. So I do need what exactly? I need... Sorry, excuse the bumping noises, moving stuff around. I could produce a list of pairs of X pairs and Y values, and then do from list with on each. I think that's okay. Yeah, we'll leave them empty there. We're doing monoid stuff like this. And now I don't have maps. I have lists. But that's okay. The function that I'm defining to consume horiz and vert can do a union with here. In fact, let's just put the list here. I don't know. I guess it's fine. Oh, I need a comma. Oh, this... Yeah, it needs to be a tuple. Okay, this is a little bit cursed at this point, but... I think that makes sense. Does this still compile? Did I screw it up? No, I didn't. Okay. It might be screwed up, but not in a way that fails to compile. Right, so I was defining a runs function, and I decided to stop for a minute to see about types. Runs of... rows? I don't know. Runs of M? Don't name the map? I don't know. No. Run, because it's not even a map yet. Is... map... go? You can never go wrong naming an internal function go. Sum.mapGo, I suppose. From list with fmapGo, because we only want to look at the values, and we should sort as well, right? Gonna have to import that. Believe it or not, sort has to be imported. From list with union, I think. So we have a list of pairs where the first we don't really care about, and then yeah, this makes sense. Where go of well, I want a function that takes in a sorted list and produces how many consecutive sequences are within it. So well, how I can zip the list with its tail to get a list of pairs of adjacent items. Is that what I want? If I had like 4, 5, 6 in a row, then those would all just be one thing. So I could zip the list with its tail. Subtracting even if I wanted. Then I get a list of the differences, but I don't think that's quite what I want. Because a difference of 1 or minus 1 is... Oh no, we know these are increasing. Because I called sort. So the differences will always be increasing. And if it increases by 1, it doesn't add a new side. If it increases by anything other than 1, it does add a new side. The problem is that the... Suppose the list were length just 1. I only had a single wall at this latitude or whatever. When I zipped the list with its tail, I would get back an empty list. And so I would think, oh, there's 0 places where we skip. So add, right, so do I really just add 1? Suppose there were like 10 spots in the wall. But they were all in a row. I would say, how many of you have a difference that isn't 1? And they'd say, oh, none of us, we're all very good. And then I would say, okay, well, add 1 to the result, and there's actually 1 wall. I think that makes sense. So weirdly, go of walls is 1 plus length filter not equal 1 of zip width flip minus of walls and tail walls. I think this sort of makes sense. Does it compile? No. Bad indentation usually means I'm missing parentheses somewhere. Yes, here. This compiles. I'm not so sure about it, but I don't know what to check. Define but not used rows and runs. Well, those are both a problem. Oh, because okay, I haven't finished defining this. All right. I need to step away for a sec. We'll continue in a moment. Okay. One thing I realized while I was away is that some of these functions should really be top-level functions so I can test them and have a little confidence that they might work. Oh, I'm not using rows here. That's why it was warning me about that. Okay, so let's define runs at least. Oops. As a top-level function. I think a line could be top-level, right? No reason it couldn't be. Ambiguous type variable. Did it infer a type somewhere? The types were fine a second ago, weren't they? I don't quite understand how that works. So this takes a list, pairs, ord k, num v. Do I need ord on v? No. A list of kv to k list of v actually. Int. Oh my god. What have I done? I thought we had all this compiling before I took these out into top-level functions. Am I wrong? Ord v. Oh, you're right. I do need ord v. Because I'm sorting the list of values as well. Okay. Really, there were two errors here? Ah, I was using eq as well. Okay, interesting. Okay, so now we could do a little bit of testing. We could say, how many sides are there? Well, we haven't finished writing sides, so we can't do that. How many runs are there if we have, you know, 1 and, oh gosh, 1 in the list, 2, 4, 3. Should be 1, right? Oh, yeah, these shouldn't be they're already a list. I don't need to make them a, yeah. But if I said 2, 3, 5, there would be 2. Yeah, that looks right. As an int, please. Could you relax? Like, okay. Yeah, that seems cool. And if I put 4 in here again, it'll go back to 1. But if instead of putting 4, I put like 0, that's 0, 2, 3, 5. That's 3 runs. Oops, what's wrong? Oh, this got put in the wrong place. Three. Yeah, so that looks like runs is doing what I wanted. A line is a bit more exciting, but I think it's probably okay. So let's go back and define sides, because we have all the tools at this point, right? Isn't it just sides horiz plus sides vert? Because horiz and vert are both valid input to runs, I think. Sides? No. Sides horiz. You're saying you thought you would have a set of coordinates, but actually you had this crazy list structure I defined. Why do you think you should have... Oh, not sides, runs. It type checks. Yeah, a line, I mean, I guess, sure, a line takes eq a and show a the way I defined it. A v2a and another v2a produces a horrible thing. Okay, real quick, we're gonna say type pair of a is an AA. Okay, guess I don't have to write this stuff twice. Pair of v2a, which really could have been a v2 of v2a, but we don't do that. To a pair of, oh, this doesn't need quite so many params. Pair of, list of, pair of, no, pair A and list of A? This is hell. I don't need that parent either. Oh, what an awful type signature. This is why it should have been an internal function, so I never would have had to admit what a dreadful function it is. It's a great function. It just isn't something you should reuse. I don't know. It would have been better if I made it just use ints, maybe. I don't know. So, like, what happens if I just run main? Undefined. Yep, I never defined num sides. But I think that is just sides now, right? Is that what I'm supposed to do? I'm supposed to multiply these two things? Instead of using the perimeter, use the number of sides. Okay, yeah, so we're multiplying them. So I think this is just... It's just this. Multiply the area and the sides, right? That's a number. It's smaller than the first number. And it should be, right? Because the number of sides a region has is always no larger than the number of fences, the perimeter. I'm a little surprised it's only smaller by a factor of like a third or something-ish. I guess the regions are fairly jagged? I don't know. I'll submit this and see if it's right. It passed the basic sniff test of being plausible. But I'm not 100% confident it's right. It is right! Okay, I mean... Considering, like, how much work and uncertainty went into these three functions, I'm pretty happy that by the time it compiled, it was just right. And how very little, like, actual feedback I was getting in my feedback cycles. Like, this is one of the things that I miss about Clojure. And, you know, maybe it's my development environment, but I don't think so. It seems much easier to me to work in the REPL in Clojure. Well, actually, maybe that is to do with my development environment. I had a much better Emacs setup, you know, with Slime back when that existed, and then nREPL. I guess Slime does still exist, but it's like a Lisp thing, an Emacs Lisp thing that had an adapter for Clojure that has fallen out of favor. It was much easier to just, like, write some function, test it on some inputs, and, like, then see if it was right. And then when it was, integrate it into the code base. It seems like it's harder in Haskell to test... I don't know. I mean, I can't think of any reason why that should be the case. Because, like, okay, yeah, Haskell has all these closures where, like, I can't really test the, I don't know, the connected function by itself because it depends on G. And so, like, you can't just extract this its own function and call it in the REPL. You have to bundle up all the stuff its Clojure entails and test that. But the same was true in Clojure. I don't know why, like, it seems to me that I have more trouble doing interactive testing of the stuff I'm writing in Haskell. Much more of the time, it's correct once it finally compiles. But I don't have confidence that it's going to be correct. So I don't know. When I finally get to testing it, it's always a bit of a hold your breath moment. Anyway, we did it. Let's get this committed. Yeah, we do need sort and all this stuff. Yeah, and align and rows. I mean, they have stupid types. They should just be using ints, but I don't know. I like being maximally general. You know what? This is insane. Give them... Just admit that A is an int every time, will you? They're more general, but you shouldn't use them at any other types in this program. And it's like just so much less horrible to look at this type. Ah! Oh, wait, really? What do you mean? Oh no, they weren't all just int, were they? One of them was like it worked on a tuple, on a pair of int or something. Alright, forget it. I'm changing it all back. Oh, perimeter? No, that's fine. This one I guess should also, but so yeah, now it's back to working. One of these somewhere, I think it's this one. It actually wants a pair of int and not just an int. So I could, okay, first of all, let's commit this, something that actually works. Day 12 part 2. And now let's go and fix the types so they're not so awful. Like this one, I really ought to just use ints. I think flood fill, this is fine. This should use ORD. But all of my other constraints are stupid. Yeah, maybe what I'll do is replace the things that are actually int with int. Okay, first of all, is that type check? Oops. No. So, okay. So that's fine. Align is confusing. We'll leave that. Here, I think I want to leave k as ORD and make v into int. Because it makes some sense. We don't care what the key is. I think that's okay. Confirming that compiles? No, of course it doesn't. Oh, well that's because I haven't fixed sides yet. I've constrained runs to only work on int, but I'm still calling it on any A. Well, sides, this has to be int, right? Because the only thing that's ORD and num and show in this program is an int. Okay, getting there. Now, where else do I have one of these? Neighbors is fine. Flood fill is fine. Align is the interesting one. Runs is fine. Eq A, show A. So oh, this is using like a pair of v2 of A? I don't even know. Well, no, it takes a pair of v2 of A. Isn't that int? It definitely is. Okay, so I think the problem is when I changed a line before, I hadn't changed sides yet. And sides was still calling a line with a more general type. Okay. Yeah, I mean, these types are just better. Question, do we make this a new commit or just pretend it always looked this way? Let's make it a new commit. Day 12. These general types are stupid. Okay, hope you guys enjoyed. Thanks for watching, and I'll see you next time.